Good evening, student. I am Mari Prasad, Assistant Professor, Department of Mechatronics Engineering, K.S.Rangasamy College of Technology, Technical. We see about the topic of basics of 8085 microprocessor under the subject of microprocessor and microcontroller. First of all, what is meant by microprocessor? Microprocessor is an electronic component or integrated circuit or ICs. It's a mini computer. Okay, it's a central processing unit on a single integrated circuit chip containing millions of very small components like a resistor, transistors, diodes, capacitors, like that. About 8085 microprocessor. It is a 40-pin chip, an 8-bit microprocessor produced by Intel and introduced in 1976. Uses a single 5-volt power supply by using depletion mode transistors, used multiplexed address and data buses. It's a 40 pins. In 8085 microprocessor contain 40 pins. This is architecture of 8085. It's a very important question in the 8085 microprocessor. Okay, the lots of microprocessor available in this market, but 8085 microprocessor is very fundamental microprocessor. Okay, first we say about the interrupt control. The interrupt control is based on the interrupts. For an example, if playing the game in our mobile phone or watching the video on YouTube, by someone is make a call, the first the priority is an interrupt, so the make a call, the call will be pop up, so this is called interrupt. Okay, trap is the most priority interrupt. Okay, this is the example for I said before, this is the example for the interrupts. Okay, INTR, INTR, RST 5.5, 6.5, 7.5, these are the interrupt. Next one is serial input control or serial output control. This is a serial input data and serial output data. Next one is 8-bit registers. Accumulator is a 8-bit register. A temporary register for if we are working in a laptop, the supplies the battery is very low, suddenly shut down, so the some data are stored. This help to temporary registers. Flags are the 5 types of flags are available. It will be come to under the upcoming slides. As ALU is an arithmetic logic unit. Okay, it perform arithmetic operations like arithmetic, like adding, subtraction, multiplication, division, and then logic will be a AND operation or operation. This will be controlled by the arithmetic logic unit. That is the next one is instruction register, instruction decoder, and also registers are there. W register, Z register, BC register, DE register, HL register. Then stack pointer, SP means stack pointer register, PC means programming counter. Then one is increment register and decrement registers. Next one is timing and control circuit. It will be clock output, and that clock signal will be given by 2.7 gigahertz using crystal oscillator. The one is ready signal. When the ready signal is enabled, the corresponding operations like whatever the operation, arithmetic logic operations, it will be when the ready signal will be enabled, the performing will be operated. Then the read data, write data. ALE means address latch enable. It's a very important control unit. Then one is zero output, zero input, input output slash memory, hold the data, reset, address buffer, address data buffer. This will be the architecture. The explanation will be upcoming slides. First, we see about the control unit. The generate signal with the microprocessor to carry out the instruction which has been decoded. In reality causes certain connections between blocks of the microprocessor to be opened or closed so the data goes where it is required, and so that ALU operates occur. ALU means arithmetic logic unit. As said before, ALU performs actual numerical and logic operation such as add, subtract, and or etc. Uses data from memory and from accumulator. Accumulator is a one kind of storage register to perform arithmetic. Always store the result in operation. All the arithmetic logic unit operations stored in accumulator alone. The accumulator is the register is used to store 8-bit data and to perform arithmetic and logical operations. Result in stored in accumulator. Flags used to check the status of the result. They already said before they are called zero flag, carry flag, sign flag, parity flag, and auxiliary carry flag. There are 5 flags are available in 8085 microprocessor. Zero flag is used to the either answer is zero or not. Carry flag is either the addition operation or subtraction operation is come, the carry is come or not, the sign is either positive value or negative value, parity, odd parity, even parity. These are the flag performance in the 8085 microprocessor. Then one is register. Register are used to quickly accept, store, and transfer the data and instruction that are being used immediate by the CPU. There are various types of registers. Those are used to various purpose. The 8085 microprocessor includes general purpose register, BC registers, DE register, and H&L register. They can work in pairs such as BC, DE, HL. These all are the stored in 16-bit data. The accumulator, flag register, 16-bit register, the stack point, and program counter. Next one is interrupt. The interrupts are signals generated by the external devices to request the microprocessor to perform a task. There are 5 interrupt signals: trap, RST 7.5, RST 6.5, RST 5.5, and INTR. INTR interrupts. The serial input and output control of 8085 microprocessor has 2 serial input-output pins that are used to read, write 1-bit data to and from peripheral devices. The SID means serial input data line, SOD is serial output data line. Next one is program counter. The microprocessor uses 16-bit register to sequence the execution of the instruction. Sequence means step-by-step process. This register is a memory pointer, memory location of a 16-bit address, and that it is why is a 16-bit register. The function of the program counter is point to the memory address from which the next byte is to be fetched. Next one is stack pointer. The stack pointer is also 16-bit register used as a memory pointer. It points memory location in read/write memory called as a stack. The beginning of the stack is defined by loading 16-bit address in the stack pointer. Next one is instruction register decoder. The temporary store for the current instruction of a program. Latest instruction sent here from memory prior to execution. Decoder then takes instruction and decodes or interrupts the instruction. Decoded instruction then pass to the next stage. Next one is timing and control unit. The timing and control unit synchronizes all the microprocessor operation with the clock and generates the control signals necessary for the communication between the microprocessor and peripherals. Some basic application of the microprocessor in general life. These application will be we have to using regular electronic gadgets in our life. Okay, without microprocessor we can't use this kind of stuffs. There are a lot of application of microprocessor in general life. Some of the application are given below. The mobile phones, digital watches, washing machine, traffic control, modems, power stations, televisions, CD player, multimeter, CRO. CRO means cathode ray oscilloscope. These applications are we used regularly in our day-to-day life. Okay. Thanks for watching, students. Keep learning and growing. From K.S.Rangasamy College of Technology, signing off, Hari Prasad.